Hi guys, welcome to my vlog. My name is Fiona Abukay, and in this vlog we will be talking about what is faults, its different types, and its importance in engineering and construction. So to know more about faults, keep on watching the vlog. Thank you. What are faults? Faults are breaks in the Earth's outside layer along which there is development. This can be gigantic or tiny. Assuming strain develops along with an issue and is abruptly delivered, the outcome is a tremor. This development might happen quickly as a tremor or may happen gradually as creep. Shortcomings might go along from a couple of millimeters to great many kilometers. Most blames produce rehashed removals throughout geologic time. During a seismic tremor, the stone on one side of the issue abruptly slips concerning the other. The shortcoming surface can be even or vertical or some discretionary point in the middle. Earth researchers utilize the point of the shortcoming regarding the surface, also known as the dip, and the course of slip along the issue to faults. Faults which move along the heading of the dip plane are dip slip blames and portrayed as one or the other ordinary or converse, which also can be called as thrust, contingent upon their movement. Faults which move evenly are also known as strike slip faults and are named either right lateral or left lateral. Faults which show both dip slip and strike slip movement are also known as oblique slip faults. Fault has three types, and these are normal fault, thrust fault, and strike slip fault. Let's move to normal fault. Normal fault is a dip slip fault in which the block above the fault has moved downward relative to the block below. This type of faulting occurs in response to extension and is often observed in the western United States basin and Range Province and along with oceanic ridge systems. Appearing from the video beside, you can see how a normal fault usually moves. Second is thrust fault, a dip slip fault in which the upper block above the fault plane moves up and over the lower block. This type of faulting is common in areas of compression, such as regions where one plate is being subducted under another, as in Japan. When the dip angle is shallow, a reverse fault is often described as a thrust fault. Showing on the side is how a thrust fault usually moves. And lastly, strike slip fault. A strike slip fault is where a fault in which the two blocks slide past one another. The San Andreas fault is an example of a right lateral fault. Seen on the video above is how a strike slip fault moves. So let's take a small time to watch this short clip about the three faults.
In a normal fault, the block above the fault, called the hanging wall, moves down relative to the block below the fault, called the footwall. This fault motion results in extension. In a reverse fault, the hanging wall moves up relative to the footwall. This motion is caused by compressional forces and results in overall shortening. A strike-slip fault is a near-vertical fracture where the ground has shifted parallel to Earth's surface due to horizontal shearing forces. If you stand on one side of the fault and the block opposite you shifts left, it is called a left lateral fault. If it moves right, it's a right lateral fault.
So let's move forward on the use of faults in engineering construction. The patterns of fault can be quite important economically. Shortcomings can regulate groundwater circulation and thus have a major effect on the mineralogy concentration and the accumulating of chemicals underneath acquisitions. They can have a big impact on landscape development. Nature, location, and disposition of the fault play an important role in the selection of the engineering site and designing of the structures like major buildings, bridges, dams, powerhouses, and tunnels. In some of the faults, fracture is a clean break, but in other displacement has occurred along with innumerable closely spaced fractures in the fault zone. The walls of the faults are often striated and silicon-sided, indicating movement. So we should know that faults are important due to their various dangerous as well as useful effects. Moving along, let's go forward and know the importance of faults. Faults cause considerable damage to rocks and are therefore real hazards in mining and engineering works. Fault breccia, which are the pulverized rocks, and fault gouge are low of strength and the weak of base material. Third is some fault zones form a potential oil traps. Fourth, to provide earthquake-proof structures, it is necessary to have a knowledge of the location and earthquake potential of faults. This is of particular importance in locating sites for dams and reservoir, hydropower structures, underground power, nuclear power stations, tunnels, public buildings, school and college buildings, and etc. And lastly, faults may create lakes, swamps, and marshy zones. So, before ending about our discussion about faults, let's go with the facts about faults. So, did you know when you spot geologic maps, a fault is represented by using a line of fault trace? Second, most earthquakes are caused by the fast movement on active faults, which releases the energy. Another fact would be the fracture surface of a fault is represented by a plane. You can call it a fault plane. And lastly, the presence of faults on Earth affects geotechnical engineering. When people want to apply slope construction, tunnel and foundation, they will always have to think about the rock masses, soil deformation, and strength of the fault.